Hey listeners, welcome back to another inspiring episode of What the Puff podcast. This is your host Mrinal along with your co-host Nitesh. Nitesh? Are you there, Nitesh? Oh, I totally forgot. Nitesh is in his hometown and under home quarantine. He'll be away for a while. But don't worry, we have a special guest this week. We have Bhavna, who is part of the performance team at my current organization. Welcome, Bhavna.
Thank you, Mrinal. Hello, listeners. Welcome to today's episode of What the Perf podcast.
So, in today's episode, we will be talking about high performance browser networking. It's a book written by Ilya Grigorik. He works at Google. I'm sure you all remember about it from our previous episode with Sajish Nair. So, without any further ado, let's get started. Let's see what tech news Bhavna has for us this week.
So, let us quickly go through the news items that I have. Upcoming open source test tool K6 has come up with its latest release V0.28. Few of the major additions in this release are logs from distributed K6 cloud test runs will now be available on the terminal from where the test was executed. So if we add console.log or console.1 in our scripts, we can see the failed requests or iterations and debug them much more easily. K6 logs can now be pushed to Loki servers. Loki servers are basically log aggregating system, something which is similar to Prometheus. In the latest release, they have also added an extension for the host and port mapping, which is majorly used during distributed testing. Now we can specify data type of fields that are sent to InfluxDB. This helps in aggregation of at the aggregation of the data at the InfluxDB level. Automatic archiving of CSV output result file. So this will give you a archived file at the end of the test.
Yeah, these new open source load test tools are really bringing out features rapidly. I remember we used K6 tool to test few of the IoT devices at our current organization. So good that these new features are getting added. I hope it helps everybody in the industry.
So the second news item is in the last couple of weeks, food aggregator platforms Zomato and Swiggy were served notices by Google Play Store for running cashback-based IPL games. Popular payment platform app Paytm was also removed from the Play Store for the same reason. This has led to a growing concern among Indian apps about Google's dominance in setting policies and guidelines. So, this has basically led to the Indian government coming forward to launch its own mobile app store as an alternative to Google and Apple platforms.
Yeah, so the point of contention between Google and these apps is that Google says it will not allow any sort of gambling apps. Basically, what these apps, Paytm, Zomato, and Swiggy were doing is they were hosting some games which were giving out cashbacks. So Google considers that as some form of gambling. So as per Google, that was a violation of its policies. So in one way, in my opinion, Google was right. However, Google has its own games on Google Pay. It also is cashback based. So we'll have to wait and watch how this pans out.
On the conference side of things, Neotis is doing a virtual conference which is called Virtual Performance Advisory Council. This is happening on October 7th and 8th. It's a round the clock marathon session which will go on continuously for 24 hours at various parts of the world. There'll be talks on performance, automation, DevOps, and various other interesting stuff from different industry experts. Do register yourself and take advantage of these talks.
Yes, this Performance Advisory Council has been happening from I think 2-3 years. And I've seen talks by many performance experts. So it is a great opportunity for everyone in the performance field to register, listen, and take advantage of these talks. Do register.
Yeah. Last but not the least, don't forget to attend the Chaos Conference being hosted by Gremlin on October 6th to October 8th. Registrations are still open if you have not registered already.
Yeah, we spoke about this conference in one of our previous podcasts. Don't miss this. Chaos engineering is a new field. Performance engineers really need to know about chaos engineering. So don't forget, register and attend this session. Thank you, Bhavna, for all the informative news. Let's get started with today's topic. So today we are going to do a sort of a book review of high performance browser networking. So the book has been written by Ilya Grigorik. He's a web performance engineer and director of developer relations at Google. So he definitely knows what he's writing. So you better read this book. How I came to read this book, right? Way back in 2018, I used to listen to a lot of podcasts. One of them was The Change Log. So I happened to listen to one episode where the host was interviewing Ilya Grigorik. So he was speaking a lot about HTTP2, its adoption across the industry, and how it came to be, and all of that stuff. So he also mentioned his book in that podcast. So after the podcast was over, I searched about the book, and I was surprised to see that it is available to be read free on the internet. So you just have to type hpbn.co, and that will download the whole book in your browser. So you can read it anytime you want for free. So how was it for you, Bhavna? How did you come to know about this book?
Oh, it was obviously from you, Mrinal. Yeah. So Brunal introduced us to this particular book. It's not just to me, but to all the team members. We got an introduction about this book, and we kind of read this slowly, like whenever it is possible, whenever we have some time, we read 2 pages of this book and try to understand what is there. And it is really a very good book when it comes to concepts and details.
Yeah. Speaking about concepts, so this book covers a lot of things related to network performance. He starts with a primer on latency and bandwidth. Then, based on top of that, he goes on building the various network concepts like how does TCP negotiation happen, what is UDP, how is it different compared to TCP, and then what is TLS, how is it different from SSL. A lot of us think SSL and TLS are the same, but there is a difference. So he has explained about that as well. And then he has explained in detail about performance of wireless networks. So wireless networks covers Wi-Fi networks, mobile networks, 2G, 3G, 4G, all of that, and how you can optimize for mobile networks. So I'm sure many of our listeners might be working on mobile apps, right? Mobile performance testing of mobile apps. So there are nuggets, there are best practices mentioned in the book about how to optimize your mobile networks. And in few of the later chapters, he covers HTTP, basics of HTTP. He starts with the history of HTTP and the challenges related to HTTP, performance issues with HTTP. Mainly, he covers HTTP2, which is currently being, I would say, it is adopted by majority of the applications in the market. So on the chapters on HTTP, he covers a lot of things about HTTP2 because he has worked very closely with HTTP2 and how you can optimize your applications for HTTP2. And in the last section of the book, he covers, what happened with XHR, what is SAC, which is server sent events, what are some new protocols that are being used like WebSocket and WebRTC. So overall, it gives you a clear picture about network performance. So, Bhavna, I know you have not fully read the book, but what would you think? What do you think are the key takeaways for you from this book? At least till the point till where you have read.
Yeah, so when it comes to TCP and UDP, all that we knew, or I knew was basic knowledge as to how the transfer happens, how the packet moves with what data in it, and all that stuff. But I didn't really know how each step is being calculated, what is the amount of time it takes. So now when I go to a new website, instinctively I check at what is the time that it spends in DNS lookup, what is the time it spends with initial connection, that is the TCP connection that it makes, and how much time is spent with SSL connection. Then what is the time that it takes for the first byte to reach the client. So all these things I'm able to differentiate and understand after reading this book.
Yeah, exactly. So once you know what these actually mean, you tend to look for them, right? So the key takeaway for me, I would say, is HTTP 2. Before reading this book, I did not know anything about HTTP 2, and I would say after reading this, I've got a fair amount of understanding about HTTP 2. So I'll just talk about one example about the performance improvement that HTTP 2 brings. The previous version of HTTP before HTTP 2 was HTTP 1.1. One of the peculiar things about HTTP 1.1 is it is a one-way channel, I would say. What it means is you send a request and you wait for the response to come back. So in the channel, either your request packets are traveling or your response packets are traveling. So once your request has been sent, you will have to wait for all the response packets to arrive at your client, which is the browser. Only then you can assemble and show the response. And nowadays you can see that every website has a lot of assets to be downloaded. When I say assets, it's the CSS files, the JavaScript files, the image files. So if you solely depend on one TCP connection to request for all of these assets and wait for all of them to be downloaded, it will take a lot of time. So as a workaround, developers came up with a concept called as domain sharding. So under that, the image files or all of these asset files would be hosted on multiple different subdomains. But even with the domain sharding, there is a limitation on the browser side as to how many connections can be maintained on these subdomains. For Chrome, it is a maximum of 6. So again, with the domain sharding in place, even if one packet was dropped in between, the whole process of TCP negotiation would start again and you would still have to wait. HTTP 2 solves this problem by changing the way request response packets travel over the connection, as opposed to HTTP 1.1. In HTTP 2, both request and response packets can travel parallelly. So this resulted in the client not waiting for the response to come back after it has sent the request. So both request and response can travel parallelly in the channel, the connection basically. So this is called as request response multiplexing. This changes a lot of things. Earlier, the workaround which was used for HTTP 1.1, which is domain sharding, is now a anti-pattern for HTTP 2. So you have to be careful when you're adopting HTTP 2 so as not to use any anti-patterns for HTTP 2. So I would say this is one key takeaway from me, and this helped me optimize my current organization's website also. Like this, there are multiple performance enhancements in HTTP 2. You can read about them in detail in the book.
So throughout the book, the author has mentioned a lot of facts and nuggets, which are really useful and informative. So I'll read out one such excerpt from the book. Decreasing transatlantic latency with Hibernia Express. Latency is an important criteria for many high frequency trading algorithms in the financial markets, where a small edge of a few milliseconds can translate to millions in loss or profit. In early 2011, Hawaii and the Hibernia Atlantic began laying a new 3,000-mile fiber optic link which is called as Hibernia Express, across the Atlantic Ocean to connect London to New York, with the sole goal of saving traders 5 milliseconds of latency by taking a short route between the cities, as compared with all other existing transatlantic links. Once operational, the cable will be used by financial institutions only and will cost over $400 million to complete, which translates to $80 million per millisecond saved. Latency is expensive, literally and figuratively. So what he tries to say is how latency is important. Like even milliseconds are being measured, and even milliseconds cost you so much. It kind of gives you an exposure to how each millisecond is cost something for a company and stuff. So I think that was one of the nugget that I like the most uh, in this particular chapter on latency and bandwidth.
So one of my favorite nuggets or facts from the book is about Wi-Fi networks. So there is a section about the various Wi-Fi bands that we have, which is 2.4 gigahertz and 5 gigahertz. The standard in most routers is 2.4 gigahertz band. I guess most of your neighbors will also be using 2.5 gigahertz band. So in one nugget, he says if you use the 5 gigahertz band, which is if your router supports it, you will get much better performance. So to say that, he has given an example of his own router. On his own router, he ran some first hop tests, and he has given the latency numbers. With 2.4 gigahertz, the 95th percentile is 34 milliseconds, and with the 5 gigahertz band, it is 1.5 milliseconds. So it makes that big of a difference. So I utilize this at my with my home broadband. So I use the when I'm close to the router, I use the 5 gigahertz band. So there's no overlapping with my neighbor's router or the wireless band. So this is one of my favorite nuggets.
Okay, so Mrinal, since you have read the book once completely, do you have any suggestions or tips for the listeners so that they can make the most out of this book while reading and also after that?
Yeah, I read this book while traveling in metro to work. So I still have to again read it once. But if I have to reread the book this time, I would read it slowly, page by page, note down what I've understood. There are some. Here, the author has mentioned a lot of commands to try out on Linux. So I would, as and when I read them, I would also try them out. And so, as and when I read any concept, I would like to, I would say, apply them, and then it will stick with you, right? So that is what I plan to do when I read it for a second time. Make notes, try out whatever is being told, and try to experiment with whatever is being told.
I think there are a lot of terminologies which we tend to forget. So making note of those terminologies will help us when we are reading further.
Exactly, yes. So that brings us to the last section of this episode, which is what the crash.
This week's What the Crash is a mix of outages and website crashes. There are two major outages reported in the last 2 weeks. The first one is entire Tesla network was down and car owners were not able to connect to their cars via the mobile app. Tesla's website was also down, resulting in their staff not being able to process deliveries and orders. Tesla has not revealed the cause of the outage.
This was my worry about connected cars. What would happen if your network goes down and I'm not able to even unlock my car, right? This is a nightmare.
The second outage was at Tokyo Stock Exchange. Trading halted for an entire day. The cause of the outage was attributed to a hardware glitch in the Arrowhead system developed by Fujitsu.
I hope nobody lost their money on this outage. And the other thing I read is how the Arrowhead system reportedly was able to handle the earthquake and tsunami that happened in Japan quite a few years back. It survived those calamities, and it experienced an outage only for a small technical glitch. This was one instance, and there was one previous instance. All you can say is monitor it continuously, right?
Yeah, true. So the upcoming elections in the US have resulted in some website crashes. The first one is Illinois voter registration website crashed because of surge in traffic. It was reported that roughly 3 times more visitors than expected visited the site.
Someone forgot to run a 3x stress test, right, Bhavna?
Yeah. So the second election-related crash was of voter registration site for Louisiana. You would expect that this one was due to surge in load, but it was due to a scheduled maintenance.
The day that this happened was National Voter Registration Day, which happens to be fourth Tuesday of every September. Somebody forgot that it's National Voter Registration Day and scheduled maintenance.
Okay.
Lack of coordination, I would say.
Game.co.uk website crashed under load because of users trying to pre-book Xbox consoles. Pre-orders went live at 8 a.m. UK time, and the site couldn't sustain the surge in demand.
This is similar to what happened with PlayStation, Sony PlayStation. I think that was reported in Singapore. This happened in UK. So this is just a glimpse of things that are coming in the holiday season, right? So
Yeah.
especially e-commerce sites, they should ensure they're running spike tests on their site.
So that's the end of What the Crash.
Thanks, Bhavna, for compiling What the Crash items. I also want to thank our listeners for tuning in. We hope you enjoyed this episode and are encouraged to read the book HPBN. If you find this podcast interesting, share it on your social media. You will see an instant quadrupling of your home broadband bandwidth when you do that. See you in the next one.